I'm Anil Kumar. As a part of exam review on calculus, we have taken up 4 examples based on trigonometric functions. Question number 1 here is, a tool shed 250 centimeter high and 100 centimeter deep is built against a wall. Calculate the shortest ladder that can reach from ground over the shed to the wall behind. So that's a maximum minimum question. Question 2. The hypotenuse of a right triangle is 15 centimeters. Calculate the measure of unknown angle that will result in maximum perimeter. Question 3. A line L through the point 01 is rotating about point 01 at the rate of 1 revolution per minute in a clockwise direction. At what rate is the point on the intersection of L and the x-axis moving along the x-axis when x equals to 5? So that is the rate of change question. And question number 4 here is, what is the local maximum and minimum value of y equals to cos x plus sin x when x is between 0 to 2 pi? Let us solve these questions one by one. Question 1. A tool shed 250 centimeter high. So let's sketch the diagram, right? So we have a tool shed which is 2 centimeter high and 100 centimeter deep and is built against a wall. So let's say this is the wall for us, right? And the shed is kind of like this. A ladder leans against this shed. So let's say the ladder could be, let's position the ladder like this. In that case, we need to calculate the shortest ladder that can reach from ground to the wall, right? So that is the length L, for example, for the ladder. We know this is 100. And this length is 250 here, all in centimeters. So let's say this is point A, this is point B, and this is point C. Now, the angle here will be same as angle at B. That is very clear, right? So let us say that the length of the ladder is x plus y, where x is AB and y is BC. In that case, we can write both x and y in terms of theta, right? X can be written as, with relation to 250, we can write x as 250 divided by sine theta, right? Since sine theta is ratio of opposite over hypotenuse. Similarly, we can write y as a ratio of adjacent side 100 over hypotenuse. So that becomes, y becomes 100 over cos theta. Okay. Hypotenuse is always greater and sine and cosine are less than 1. So it makes sense, right? Now once we know that, we can actually, to find the shortest length of the ladder, we can find the derivative of this with respect to L's, with respect to theta. So dl d theta is equals to derivative of this. You can actually write this as cosecant theta and then do the derivative, or you could do direct also, right? So think like this. We have 250 sine theta minus 1. Think like this. Plus 100 cos theta to the power of minus 1. So it becomes simpler. You can apply the power rule. Is it okay? So that gives you minus of 250. So we are avoiding the formula of cosecant and secant, since you may not remember it. Minus of sine theta, right? To the power of minus 2. So that becomes minus 2 times derivative of sine theta, which is cos theta. Does it make sense? Right? So you could get like this. Plus, here again, minus, we get derivative as minus of cos squared cos theta to the power of minus 2, right? Times derivative of cos theta, which is minus sine theta. Does it make sense? And of course, I forgot to write 100. Is it okay? So you go write like this. In a way, what you get here is minus 250 cos theta divided by sine square theta. Plus and minus becomes minus, and that minus makes it positive. So here we have 100 sine theta in the numerator divided by cos square theta. Is that clear? Well, you could have written directly derivative of cosecant theta and secant theta also. Okay. Now, for maximum or minimum, which we say critical number, dl theta should be 0. So we can equate this to 0 and then find the value. Is that clear? So multiplying, or we can just take this side to the other side. We get 250 cos theta divided by sine square theta equals to 100 sine theta divided by cos square theta. Now if you cross multiply, so what we get here is that gives you 250 over 100 equals to, if you cross multiply, you get sine cube theta divided by cos cube theta, correct? Which is tan cube theta, right? So we know tan cube theta is 250 by 100. So from here we can find what theta is. Now the angle theta is actually between 0 to 90 degrees, right? To form a triangle in this fashion. Now we know that somewhere in between we will get the minimum height, since when theta is approaching 0, in that case 250 by sine theta approaches infinity, right? So this becomes infinitely large. But when theta approaches 90 degrees, cos theta approaches large number, right? Well, when we are working with trigonometry, we should actually do it in radians. So we'll write this from 0 to pi by 2. Is it okay? So anywhere in between, we are going to get minimum, right? Now, let's find what angle theta is. So we know tan theta is cube root of 2.5. So this gives tan theta equals to cube root of 2.5, right? And let's convert our calculator to radians. So we get 4. So that gives you radians. Now theta is equals to tan inverse of cube root of 2.5. Is that clear? Okay, let's do it. So we have shift tan inverse of cube root of, so that is cube root of 2.5, which is equal to, in radians, theta is equals to 0.93579. Okay, whatever. So that gives you the value of theta. Now, for this value of theta, we can find what L is, right? So let me push this page a bit. Okay. Now we know this is minimum, since when theta approaches 0 from the positive side, L approaches infinity, right? Since sine theta approaches 0, when theta approaches 90 degrees, let's say minus, right? It cannot be 90. In that case, the length again approaches infinity because cos theta approaches 0. Do you see that part? So therefore, anything in between is minimum, right? So the minimum length L will be equals to 250 divided by sine of 0.9, let's say 358, plus 100 divided by cos of 0.93, let's say 58. Is that okay? We'll approximate. Let's approximate this answer. So what we get here is, we already have for 1, we can say 250 divided by sine of our answer. We get 310.5. So this is 310.5. Let's push this. Plus 100 divided by cos of 0.9358 equals to 168.58. Let's add them. So this much plus 310.5 gives you 4.79. I mean 479. So it gives you 479, right? Okay. So what we get here is 479 centimeters, which is approximately 4.8 meters. I hope the solution is absolutely clear. Let us review. We actually wrote length of the ladder as x plus y. X is 250 related with 250 divided by sine theta. Y is 100 divided by cos theta. Took the derivative, found the critical number, equated that to 0, and then figured out that the angle in radians is 0.9357. Substituted that value to find the length of the ladder, 4.8 meters or 479 centimeters. Perfect. Now it's important to understand that theta can be within 0 to pi by 2. I should say 0 plus and less than pi by 2. When theta approaches 0, sine theta approaches 0. So 250 divided by 0 will be infinitely large. But when theta approaches the other extreme value of pi by 2, cos theta approaches 0. So in any case, anything in between will give us a minimum. Do you understand? Therefore, we know this is a minimum, right? And that is the justification. By testing endpoints, is that okay? Since there is a closed interval, theta is between 0 to pi by 2. Now let's move on to question number 2. Question number 2. The hypotenuse of right triangle is 15 centimeters. Calculate the measure of unknown angle that will result in maximum perimeter. So let's sketch our triangle. This is a right triangle with hypotenuse as 15 centimeters. Let the angle be theta, this side be x and the other side be y, right? So that's the right angle triangle. So from the triangle we know x over 15 is cos theta, and that gives you x equals to 15 cos theta, right? And we know y over 15 is sine theta, so we can write y equals to 15 sine theta. So what is perimeter? Perimeter is sum of all three sides, which is 15 plus x plus y, and that could be written as 15 plus 15 cos theta plus 15 sine theta. Clear? Now, to maximize the perimeter, we'll differentiate the perimeter with respect to theta. That constant will be 0. Here we'll get minus 15 sine theta, and the derivative of sine theta is cos theta, so we get plus 15 cos theta. For critical number, this is equal to 0, right? So this is 0 for critical number. And therefore, we can now take it to the other side and say 15 sine theta equals to 15 cos theta, or dividing we get tan theta equals to 1, and this is when theta equals to pi by 4, right? So remember, in this particular case, we are taking theta, which is in fact between 0 to pi by 2. We'll write this as a closed interval. However, we know that if it is 0, we'll kind of get like this, right? So this will coincide with the adjacent side. Now, you should remember one thing, that cos theta is going to be, so anyway, let's figure out the dimensions also and see whether we get maximum or minimum, right? So first we got critical number as pi by 4. Now if theta is pi by 4, in that case, what is the perimeter? Let's find this out. So in that case, perimeter will be 15 plus 15 cos pi by 4 plus 15 sin pi by 4, correct? So that gives you 15 plus pi by 4 cos pi by 4 1 over square root 2, right? And this is also 1 over square root 2, right? So which is 15 over square root 2. So that gives you 15 plus. So if I take 15 common, I get 1 plus, and here I get 1 plus 1 as 2 over square root 2. Or we could write this as 15 1 plus square root 2. Is it okay? So that becomes the perimeter. So whatever is the length of hypotenuse times 1 plus square root 2. Now let us check if this is the maximum or minimum, right? Because this is a critical number. So if theta equals to 0 radians, in that case P will be equals to 15 plus, for theta 0, sine theta is 0, right? So we have 15 plus 15, which is 30. And if theta equals to pi by 2, in that case, we know cos theta equals to 0, so P equals to 15 plus this 15, right? So either case, we get 15 plus 15 as 30. But in this particular case, we know square root 2 is more than 1, right? So in this case, what do we get? Let's calculate. So we get 15 within brackets 1 plus square root 2, bracket close, equals to 36.21. So we get 36.21 units being centimeters, right? So comparing the values, we know maximum perimeter is equals to 36.21, but we need to only find the unknown angle. That is for angle theta equals to pi by 4 radians. Is it okay? Radius. So that is how it will be solved. Now let's take up the other examples. I am Anil Kumar sharing with you a very interesting question on rate of change, application of trigonometric functions. Question number 3. A line L through point 01 is rotating about point 01 at the rate of 1 revolution per minute in clockwise direction. At what rate is the point of intersection of L and the x-axis moving along the x-axis when x equals to 5? So let's sketch this to understand the situation, and then we'll figure it out. So we have a line kind of like this, which is rotating about a point 01. So that's your y-intercept. This is the point 01, right? So 01. So when it rotates, it's rotating in clockwise direction. It's rotating in clockwise direction. So the rotation is given to us as 1 revolution per minute. Now this will be considered negative since it is clockwise, right? Since it is clockwise. Is that clear? So 1 revolution per minute is the rate of change of angle. So if I say that this angle here is theta, let's keep this angle as theta. In that case, what we are saying is that d theta dt is equal to 1 revolution means 2 pi. So I can write this as minus 2 pi radians per minute. Correct? So that becomes d theta dt. Now we want to find at what rate is the point of the L and the x-axis. Let's say this is the x-intercept. So this point is moving. Let's call this point as A. When x is 5, when this x is 5, that is what it is. We know this is fixed at 1. Let's also calculate, let's call this point as B. So what is AB equals to? Let's write down here. AB will be square root of 1 square plus 5 square. Correct? That is AB, hypotenuse. Okay, so which is square root of 26. AB. Okay. Now, we can relate, let's say this is x any time, right? If this is x, in that case, how is x related with theta and 1? So that becomes the opposite side, correct? So that is the opposite side. So we can say tan theta is equal to x over 1, or x. Is it okay? X over 1, we can say that. Now, let's differentiate both sides with t, right? So let's differentiate with respect to time. So if you do that, you get secant square theta d theta dt equals to dx dt, correct? We actually need to find dx dt when x is 5. That's the whole idea, right? So we need to find dx dt when x equals to 5. This is what we need to calculate. So that's what it is. We know d theta dt is minus 2 pi. And for the given angle theta, what is secant theta? Well, secant theta will be hypotenuse over adjacent side. So in this case, secant theta will be hypotenuse square root 26, right? Over 1. So secant theta is square root 26. So we know this. We're going to substitute this here. So substituting, we get square root of 26 whole square. D theta dt is known to us as minus 2 pi, which is minus 2 pi, is equals to dx dt. Correct? So that is what it is. Now, we can just multiply this, and that is 26. Right? So we get minus 52 pi equals to dx dt. Does make sense, right? So that is what it is. The units will be, well, we are not given any units along this side per minute. So, okay. So whatever units per minute. So we get our answer, which is the rate of change at this instance of time will be, it is decreasing, right? That negative means decreasing. Minus 52 pi units per minute. Okay. So that is how we are going to solve it. I hope it is absolutely clear. Feel free to write your comments and share your views. Okay. Now let's move on and take the last question, which is question number 4. Now it says, what is the local maximum and minimum value for y equals to sine cos x plus sine x when x is between 0 to 2 pi. So it's a simpler question. We have y equals to cos x plus sine x, where x is between 0 to 2 pi. I'd like you to pause the video, answer this question, and then look into my suggestions. We are looking for local maximum minimum, so we find the derivative. So we say dy dx is equals to minus sine x plus cos x, the derivatives, right? Now, for maximum or minimum, we say the critical number, this should be 0, right? So for critical value, this should be equal to 0. So we say 0 equals to minus sine x plus cos x. Sine x will be equals to cos x, or when you divide, you get sine x divided by cos x equals to 1. So that gives you tan x equals to 1. And between this, when is tan x 1? Positive 1, when either you are in quadrant 1 or in quadrant 3, right? The angle being pi by 4, right? So this becomes 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, or this, right? 5 pi by 4, correct? So those are the angles. Okay, so we get from here, let's write down here, two values, x equals to pi by 4 and 5 pi by 4. Now, both these values will give us two different answers. Let's calculate the value of y. That should be simpler. So we'll just calculate y. So y equals to cos pi by 4 plus sine pi by 4, and also y equals to cos 5 pi by 4 plus sine 5 pi by 4. So this is 1 over square root 2 plus 1 over square root 2, and this value is negative of this, right? Negative 1 over square root 2, negative 1 over square root 2, correct? So that gives you the value as 2 over square root 2, or just square root 2 positive, and this will give you negative square root 2. Perfect. So we get our maximum and minimum values. So the answer here is maximum is square root 2 and minimum is minus square root 2. Does make sense, right? So that is how you could actually solve this question. With this, we come to an end on our 4 examples which we took for application of trigonometric derivatives. There are many more in my videos. I'll provide you with some links. Hopefully, this gives you a fairly good idea about how to apply your learnings and solve such questions. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thanks for watching and all the best.